Hi guys, welcome to the second class. Uh, okay, let's start few examples so that we can understand this LTI system. Now another example is there. You have to find out whether this is LTI or not. This is example 4. Now y of x equal to 3x t plus delta t. Okay, now find out whether it is a LTI system, linear time invariant system, or not. Guys, please find it out. Do it in your own hand. Otherwise, you can't understand. Guys, you can see this example. Please do it your own, and then I will explain whether this LTI system it is there. Miss Miss Poonam Preeti Kumari, please do it in your own copy and examine it. Then I will explain. Okay, guys, please tell me whether this is a LTI system or not. So we have to examine it. First, is that a linear system? Yes, it is a linear system. Look, it is a linear system because this
Ye-
type of things is there, but it is not a time invariant. It is not allowed because if I put some 3x where x is 0, then y also 0, but this delta t, this impulse function is there, this impulse functions is there. So this is not a particularly not 0 because something is there, some impulse function is there, some impulse functions is there. Huh? So so as this term is there, so this is not time invariant. So this system is not LTI system. Okay. Another way we can determine that. Another example 5, that is whether this y of t equal to x of t minus t, is that a LTI system?
Yes,
Is that a LTI system?
so it is time variant system, so it is LTI system.
No, you can't say this is a LTI system. Now, how could I determine this? Look, if I give the Laplace transform, we can get that is y s equal to x of minus of s. Up to this, it is clear. Minus of t means minus of x. So you know transfer function must be is just like that ys equal to x of s. Okay, but in this case if you find out this transfer function, then it is y of s equal to x of minus s. Is that these and these are same? These are same? No, this is
No,
not
sir.
same, this is the minus. So it is looks like a LTI system, but no, as per the Laplace transform system Laplace transform examination, it is not like this. You have to coming this positive both side. Then so this is not also a LTI system. Okay, and now we go for some. This is also only for checking. Okay, but some questions are there. Uh, how or how we handled some LTI system. In this next topic, we are going for some LTI system. It will confidently it is tell that you can tell that is yes, it is a LTI system. But we can see some operation of LTI system. Okay. Now we are going for the example 6. Example 6. Look, you are given some input and output. Okay, if you give some input, then you can get output. But whenever we change this input, you have to find out whereas the output will be. So if this is your input, this is your input, that is t equal to 0, that is 1, that is 2, that is also 1. So your input is just like this. Input is just like this. That is 1, that is 2, that is 1. So that is your input function. Okay, input function, that is t. So output will be just like this. Your output is that is 1, that is 2, that is 1, that is 2. So output is just like this, that is 0, that is 1, okay. So that is 2, so it will be output, okay. So it is a also a LTI system, but you have to find out, now, find out, this is x of t, okay, or you can say that is x1 of t. You have to find out if input is that is 1, that is 2, that is 3, that is 4, that is 5, 1, 2, 3, 3, 4, 5, if, and that is 1, if this type of signal is given to you, then find out what will be the output, what will be the output, okay. So second question, that is 0, that is 1, that is 2, that is 1, that is 2, that is 3, that is 3, that is 0. If this type of input is given, then find out what will be the output, okay. uh, that is 1, that is 2, that is -1, okay. So this type of input, say this is x x4 of t, and it is, I just indicated this way. So what will be the output? So guys, you can see three questions are there. This is the LTI system, and we have to, if you are putting input just like this, then you can get the output just like this. But whenever your input is changed, here is a LTI system, say here is a LTI system you are putting, okay. Say there is a some circuit is there, something is there where if I put this xt, then we get this type of output, okay. Means square wave, this is a rectangular wave. Rectangular wave is changed to a this type of triangle, okay, triangular wave, and the shape is just like this. So what will be the output if I put this type of result, this type of result, this type of input? And in previous classes I have show you so many this type of representation of this step function. How could I represent this step function, and then we can get some operation, so many operation, magnitude scaling, time scaling, okay, uh, time shifting, delay, advancement. So just apply this type of concept, then you can do this. Just these three questions you have to find out. So if you have a good knowledge about the signal and this graph theory, means not graph theory, this type of graph, then you can easily do this. And in previous classes, I have explained this only this step, unit step, ramp functions, impulse functions. Just do it in your own copy and please show me what will be your result and how could we do this. Guys, please tell me, time is very less, we have to complete it. Okay, if you don't say anything, then I have to perform this. Okay, so you can see the expression. This is also one. So how could I do this? First of all, you are it is provided that if this type of input is given, then only you can get this type of output. So anyhow, your all input should be represent just like in this way, in this pattern. Then we can apply it for the input. Say it is your square hole, then you can put only the square things, not a round things or not a rectangular shape. Okay, above this diameter. But here, if there is a round shape hole, then you can put only the round shape materials. If you put some higher this square shape, then it will not enter. So as this type of input is there, then you have to convert it in this way. Okay, so then we can easily get this type of signal. So here you can see there is 3 and 5, means if the if the signal is there 0, then it will be shifted to the 3. It will shifted to the 3. So this is the advancement. So we can say that is t advancement means minus of 3. That is the signal. So here is x of t is there. So we have to put, if x of t is there, then we have to put x of t minus 3. Here x of sorry, this is x. Here x1 of t, it is, you can say just x1 of this. This is x2. So x2 is just x1 of t minus 3. If we shift this minus 3, then we get this type of signal. So here output also shift. So output also shift to this from 0 to the 3. Okay, so this origin will be 1, 2, 3. This origin will be, this is 3, this is 4, and this is 5. Okay, this is x of 2. Okay, and this is t. X of 2 means, x of 2t means x1 of t minus 3. This type, these things. Okay, so you can understand this is the application. So any scaling operation also applicable in this LTI system. Now this point, you can see this is a 3 and here this is a 1. So if you're in, guys, just perform it, because this is a very easy example, and this is a conceptual. If you don't perform in your own hand, then you can get any conception for the signal and system, and later on you just feel a boring subject. Look, this is a this is, if this signal is there, this is 1 unit, and if I put this, means there is a multiplication operation. Okay, and which type of multiplication? Just remember this. This is called amplitude multiplication.
Yes, sir.
Remember, amplitude
Yes.
multiplication. So if
Sir, high
our
रैम
x, yes, tell me.
रैम सिग्नल का सर हाइट सर 3 तक पहुंच जाएगा जब
हाँ
ट्रायंगल इस
हाँ,
साइड बनाएंगे
yes, yes. Look, your
और
x1
फिर
is,
जी origin से स्टार्ट होकर 2 पे फिनिश होगा।
yes, AV2 में फिनिश है, AV2 में फिनिश है, मतलब T is fixed. So time multiplication or time shifting is not required, or nothing is operated, but only the amplitude is changing. So this is called amplitude multiplication. So if x of t is this signal, then this is, say this is the x3 signal, this is x2 x1 signal, this is x1 signal, this is x2 signal, this is x3 signal, and this is x4 signal. Okay, just I'm giving the name. You may put xa, xb, xc, whatever may be. Okay, so this, if this is x1 signal, if we put some 3 into multiplication, then we will get that is x3 signal. Okay, nothing more. That is amplitude multiplication. You can see this is the amplitude multiplication. So what happens in this case? What happens in this case? Because this portion is 1 to, this portion is the xt, and if you multiply this 1 time, 2 time, this is the 3 times. So this is 3 into this. So this signal also changed. Same is there, 0 is there, 0 is there, 2 is there, yes, 2 is there. So only this is 1, this is 2, this is 3. So it will change up to this 3. It will also apply some multiplication, and so amplitude multiplication. So guys, could you understand this thing? Just simple operation is doing here. Now
Yes,
here this is, yes, yes, tell me.
understood sir।
Okay, okay, thank you. So so this is the LTI system operation. Okay, now here is the twist. In the example of 3, example, in this third example, you can see there is a some zigzag model. So if your x1 is just like this, if your x1t means, what are the given function is that your, this is 2, this is 1. So this is a, just like a rectangular shape function. So this is a rectangular type function, because this is 1, this is 1, and this is 2. Okay, so how could I solve this? How could you solve this? So your, this input signal you have to arrange such a way so that this system should be a LTI system just like this, and simultaneously you have to put in the form of this input signal, means in the form of x1 type signal, x1 of t. So x4t should be anything, maybe this is the coefficient, maybe the something is there, so that in that way, that x1 term, then you can apply for the output. Otherwise you can't apply this, because this LTI system is only taking this x1 input. So any term of the x1 could be changed up to this, But any other terms, or if maybe not LTI system, then it will not the same things. Okay, so how could you represent this? How could you represent in term of x1? First of all, this is a rectangular signal, so we can apply for the rectangular term. Look, this signal is a combination of two two signal. Say this is a signal, and this is a another signal is there. This is a signal, and this is the another signal. This is another signal. So these two signal, if two signals are merged over here, two signal are merged over here, then we can get this type of signal. But how could I merge this? It may be many way, but we have to choose such a way so that we can represent it in this form. Okay, you can see uh, this is one, this is one, this is two. First, your one signal, x1 signal, x1 means your original signal is 2 and this is 1, and if I add with this half of rectangle means if this is a rectangular signal, if I put some one by one and this is 1, okay, so then it will be coming half t rectangular signal, that is t by 2, t by 2, because your t is 2 and your 1 by 1 means if we just times it, this is called time scaling. If I apply some, this is t, if I put t by 2, then it will be squeezed into a 1 by 1, and rectangular signal is 1 means there is a 1 and there is a 1, okay, plus 1 minus 1. If I add these two signal, look, so what happens? This is a rectangular, this is a rectangular, so this is 1 by 1 minus 1, this is a 1, this is also I am superimpose on this, this is also a one signal, but it is this signal is in this type. So here you can see this two unit is there, first unit is for orange and second unit for your black, because this is also one unit and this is also your one unit. Okay, this orange unit also one unit, okay, one unit, and this is your one unit, so one unit plus one unit in orange, one unit it in black, so it became two unit. So here it will, because it is a superposition theorem, it will also apply some superposition theorem, so it will be this type of signal. But what is the expression? What is the expression? Expression is this is your x of t and this is your rectangle t by half, means time shifting rectangle, time scaling, not shifting, this is scaling, means your scale is changed 2 to a half, okay, each side it is half, so it is called time. What is this? Time shifting or scaling? This is a scaling operation, not shifting. Shifting is plus or minus, or scaling means multiplied or divided. Okay, so this is x4 signal could be represent in x1t, this signal, and plus this signal. So plus rectangular signal t by 2. So this is also a expression of x1 term. This is also a x1 term. X4 is x1 term. But is that a LTI system? The question is that a LTI system? Is
Yes, sir.
no, sir. Is that a LTI system? Linear time invariant system? You have performed so many questions. So if it is a linear system, first of all, here t by 2 term is there. So if t by 2 term is there, then it is not actually linear. Okay, but linear system is not. And another way, we told if y, if you put x of t equal to 0, x equal to 0, then y should be 0. But in case if this portion x portion is here is y also 4, this means to this. So this means if you xt is 0, this term is no x term is there, so only t by 2. So this is something is existing. So your y does not 0. It may be x is the 0 but y is not 0. So in very fast I told you the question is that time invariant system, if x is 0 then y have to be 0. But here if x is 0 y is 0. No, y is not 0 because this term is added. So if any added term is there, if added term is there without x, added term but without x, if there is some x, then it is also linear or in time invariant. But here no x term is there. Rectangle of t by 2, where is any x term? No x is there. So if I put any x, it will not affected. If there is something x is there, then it will be a time invariant, because if I put 0 also, then it will give some 0 or infinity or anything will be there. But here is no x term is there, without x term is added, so it must have some value over there, so y is not 0. So this is not LTI system. So in this way, if you go, if you represent it, so this system will not give your output in this way, because this is only allow this LTI system. So we have to arrange in such a way so that it will become a LTI system, means this term should be a x term. So if I do this another way, look, if I do this another way, so your example is given in this way, in this such type of this. So this is -1, this is 1, this is 2, and this is also your 2. Yes, this is also 2. So this is your input term. Input is x4 of t. So we have to arrange such a way that this system became a LTI system. Then we can get. Okay. So only 10 minutes left, but we have to do hurry. Okay. So if I arrange break this part in such a way that is x1 of t, that is your original signal that is coming in this way, that is coming in this way, that is 1, and that is 2. Sorry, this is look like opposite direction. This is 2. Okay, this is not 2, then it will look wrong. This is 2, this is 1. So this is your original signal, input signal first time. And if I add another signal, not rectangle signal, it is the time shifting signal. If I time shift, say x1 t plus 1, t plus 1, what will be? Then it will shift. If there is a plus, then it will going to the minus. If there is a minus, then it will advancement. So if just this signal, here is 1 is there, this will be shifted over here, this will be shifted over here, this is 1 also, this is shifted, this is -1. Just if I add this signal, if I add this signal, what happens? You can see here is 1 by 2, that is 1 by 2, and I am doing this signal in this way. And if I do this, if I do this, this signal is there, that is -1, that is 1. This is this signal is orange color, and this signal is the this signal in the brown color. So you can see here it is -1, 1 and 2. Here is 2 overlapping is there. One is this portion is overlapping and this portion is overlapping. So if I take one by one unit, and this is also 1 unit, so it became a 2-unit function because it is obeying the superposition theorem. So this signal is looks like this. Is that right? Is that correct? Then our signal will be x1 of t plus this signal plus x1 of t minus, sorry, this is plus means here. So you can see this is a plus, this is a t, this is a plus function, this is 1. Plus means shift away. So this x4 of t equal to x1 of t plus x1 of t plus 1. So is that a LTI system? Is that a LTI system? Yes, yes, it is a LTI system, because any of t function, if I put some 0, if I put some 0, then y of t also 0. Okay, so it is a LTI system. Then we can apply this. So then we can apply this. So if I go for the output, what happens? First for the x1 of t, we get x1 of t, we get which type of signal? Which type of signal? This type of signal. Means 1 to 2, output will be 1 of 2. No, this yes, 1 2, and here is also 2. So your output will be, here is 2 and here is 1, here is 0, here is 2 for the x1, and for this purpose this is time shifted, one time shifted. So x1 of t plus 1, if I get the output of this, then it will be just like this, because this is coming here, this is coming here, this is also 2. So if I add this output and this output, what will be the output? Look, here this portion nothing is there, but here is something is there. So easily we can get, this is 1, this is 2. This portion will be achieved. This portion will be achieved. Nothing is less. But here something overlapping is there. This portion is there. This is positive slope and this is the negative slope. So what happens? This 0 to 1, this one you can see, after this one here, from here it is negative, this 2, this is 2, this is 1. From this 2 position, something is going to the upper side, here is 0, and here is coming to the downward, means there is a negative. So negative and positive, if slope, here is the slope, so negative and positive, it becomes static. So 2 position it signal will be the static, because negative slope, negative start from 2 to 0 and positive start from 0 to 2. So this portion and this portion, it will be just nullify, and this is in this portion. And after then this is coming 1 to 2. So 1 to 2, this is no other signal is there, because it is also nullify, this is also nullify, this is also nullify. So only this portion is there, so you get this signal. So this is the output signal. And guys, could you understand this thing? So this is the beauty of signal system. If you initially you can understand, then total signal system became easy to you. Otherwise, it will become a boring paper. Okay, guys,
Yes, yes.
have you any question regarding this? So many things are new to you, just like Laplace transform, Fourier transform, convolution theorem, jet transform. But you can see in your syllabus, it will be occupied your different module. So whenever we enter this module, then again explain. But here you have to know how the signal is operating, and very initial level graph, because after then you never get this type of graphical representation. You get only this type of expression and expression. Only signal system is depends on expression. But first time I mm, don't want to follow the expression only. We can also follow the graph. Then you can imagine, imagination power will be increased. Then easily you can go for the second, third, fourth system. And it is generally actually this type of problem is asked to your gate level question. Okay, so gate level is a very basic thing. Okay, guys, today I stop here for the second class, and thank you.
Thank you, sir.
Thank you, sir.
Welcome. Have a nice day.